Hello guys, hope you're doing well. My name is Mahmoud Kiasari and welcome to the new chapter in this channel which is about electrical circuit. Unlike the previous chapter that we were only talking about math, at this part we are going to be choose one of the very important concepts and topics related to electrical engineering concept, and the very basic thing would be about electrical circuit. So right now we are going to learn how we can apply there's all of those mathematics, all of the advanced algebra, and anything related to that we learn, and we are going to put it inside the electrical engineer section, especially electrical circuit, and see that how actually we can use that in the real world. So be with me that we were going to talk about what would happen in this specific course that is going to be huge, covering and related to anything, resistance, capacitors, inductors, all of the laws and rules related to that. Not only we are going to understand them, we are going to use them in specific examples. We are going to understanding them, and after that we are also going to have some labs. It means that we are going to do some practical work just without some kind of start the whole work itself, without some kind of start the chapter. I'd rather to have this guide or this part as the chapter number 0 in order to show you that what actually you have to expect from this one. Without further ado, let's talk about it. So again, as I just told you, or this chapter is going to be a blueprint that we use it in order to being master in electrical circuit itself. So we are going to have the comprehensive and 40 chapter curriculum of design to transform all of the fundamental knowledge into expert level application. So it means that we are going to start from the very basic stuff, of the Ohm's law. So we are going to start from the Ohm's law to AC power systems, and every component of your expertise is going to be meticulously planned and built. So whether we are going to start from the module number 1, this module number 1 is going to be about the fundamentals and about the Ohm's law. Then it is going to follow with the number 2, or the module 2, we are going to talk about the DC network analysis. Then we are going to talk about transients and energy storage. And then we are going to talk about the AC circuits and phasors. And finally, we are going to touch the power systems and design application. So in total, you have to expect that have around 34 to 40 hours of in-depth instructions. We are going to have 40 sequential chapter across 5 integrated models itself. We are going to put our focus heavily on solving examples and lab. That means that we do have more than 200 of solved problems in order to help you that understand everything in detail. And finally, we are going to have 7 hands or some kind of practical labs, hands-on and practical lab in this module itself. So let's talk about it. Let's talk about this pathway actually we do have. So this pathway is going to have 5 different stages. We do have the journey to become expertise in electrical circuit. The module number 1 is about the foundation. It is going to be about the mastering DC circuits. By the way, don't worry about right now everything related to your knowledge that you don't know anything about them. That is totally fine. At this point, I'm trying to give you what is going to happen in the future for our work itself. So this is just going to be chapter number 0. You don't have any knowledge. If you have any knowledge, that is good, but if you don't worry about it. The module number 2 is going to be analysis. We are going to talk about advanced DC circuit techniques. Module number 3 is about the transition. We are talking about we are going to move from DC to alternating current, or AC. Module number 4 will be about the synthesis. It means that we are going to use the advanced AC analysis and resonance and anything related to that. Module number 5 is about the application, how we can use everything that you just learned in our real world scenario. As I just told you, we are going to have 3 core knowledge or 3 core toolkit. The first thing is about learning to completely make sure that you completely understand everything. We are going to solve as many questions as possible. Right now, we do have more than 200 number of examples, but if you need, we can have more and more. And finally, we are going to build, because if you don't have any kind of lab circuit, or if you don't have any kind of building, how you would expect that you can use it in the real world application. That's why in this part we are going to use the real and actual lab stuff like breadboard, resistors, capacitors, inductors, oscilloscope, and anything related to that, and we are going to show you that how you can use all of your knowledge in the lab itself. So let's start from the first module. As I just told you, first module is trying to focus on the foundations. They are going to master the DC circuits, and this guy is going to be from chapter number 1 to chapter number 12 itself. The key concept that we are going to cover, the very first thing is about the definition, is about atomic theory and current. We are going to understand the electricity and at the atomic level. Then we are going to talk about the big three. As any other kind of electrical circuit courses or anything related to that, there are three important parts: voltage, current, and resistance. And we are going to see their definition, what are their relationship. This is going to lead us to the next part, Ohm's law mastery. We are going to have deep dive into the V equals to R times I, and we are going to see the most critical equation in electronics itself, which is going to be chapter number 3. Then we are going to talk about the power of energy. We are going to calculate in power, which is watts, and energy, kilowatt hour, and we are going to see that how we can use them and why we do have them. Finally, we are going to talk about the circuit configuration. We are going to complete the analysis of series one, parallel, and in circuits, including the KVL and KCL, which we know as the Kirchhoff's law from chapter number 6 to number 10. The core activities over here is that the very first thing, as I just told you, is about learning. First of all, we are going to learn anything related to voltage divider, current divider, or maybe the Ohm's law, anything related to that. Then we are going to solve. We are going to dedicate our time to problem solving because as I just told you, this is going to be a very important section. So from chapter number 7 that we learned something related to series parts and series circuit, and chapter number 11 to the parallel part, we are going to see so many examples, at least 16 different examples that you guys can completely understand what is going on. And finally, we are going to build something. We are going to the lab, and actually we are going to build some parts for the course itself. So the lab section actually needs a little bit of information. The lab part, actually, I'm going to build something using the breadboard and any specific materials and some kind of the parts that we need. But just before that, in order to make you familiar what is going on actually, rather than just doing the calculation by ourselves, we are going to use the software simulation. And this software simulation could be some kind of thing that you anything so free online software, it doesn't matter. The only reason that we do have that we are going to see that our calculation works based on the simulation. Then we are going to apply the simulation into the real world, some kind of example and your real world application to see that everything works aligned with each other itself. Then we are going to chapter number 2. The module number 2 is going to be analysis. We are going to talk about advanced DC circuit techniques. It's going to be chapter 13 to 20. As I just told you, we are going to have the series and parallel networks. We are going to see that what would happen if you do have them and if you would like to simplify them. Then we are going to talk about electromagnetism. It means that we are going to explore the magnetics, the MMF, magnetic force. We're talking about the reluctance and the principles behind all of the relays and solenoids that you have in your real life. Then we are going to talk about inductors. We are going to understand the energy storage in magnetic field and the property of inductors, those L or those big coil guys, actually what they mean. Finally, we are going to talk about the LR time constant. We are going to analyze some kind of the transient time. We are going to have the response of this inductive circuit. We are going to include the 5 tau rule that I will completely talk about it. So our purpose for this course is to learn. We are going to have 2 full chapters dedicated to advanced series and parallel problem solving strategies. Then we are going to solve. We are going to tackle the complex ladder networks, bridge circuits, and troubleshooting scenarios. And finally, we are going to build and simulate the problem that we do have in our circuit itself. Then we do have the next part. It's not actually the next part, it's some kind of the middle part. Again, we are going to talk about the learn, solve, build methodology in action, and we are going to see that how actually we are going to use that, especially when we're talking about the theory to understanding. Again, as I just told you, in each of these 4 chapters we are going to have self-contained lessons. We are going to break down the complex theory with clear explanation, visual aids, and step-by-step example. Then we are going to put a step in the solve part. We are going to have the from problems to strategies. We're going to go beyond formulas and dedicated sessions only focus on the strategy, showing how you can approach, simplify, and verify solution for multi-step analysis. We are going to design and troubleshoot the problems. And finally, when we make sure that we completely understand it and we know everything about related to theoretical, we are going to have 7 different comprehensive lab that you actually guys can see what's going on in the real world scenario. So let's move on to the next module number 3, where do we have the transition. It means that we are going to move from DC or direct current to alternative current, which is going to be about the AC part. So at this point, we are going to talk about the capacitor. We are going to talk about the theory, construction, and the behavior that these guys has in DC circuits, including the RC time constant, which would be the chapter 21 to 22. Then we are going to talk about the AC part or the AC generation. We are going to see that how we can have this sine wave. Its anatomy is would be about the peak, RMS, frequency period, and anything related to that for chapter number 24. Then we are going to talk about the reactance, introducing the X of L and capacitive one, X of C. We are going to see those reactants and just talk about the frequency dependent opposition to AC current, just like the way that we had for resistors, but at this time we do have capacitors and inductors. And finally, we were talking about the phase relationships. We are trying to see the concept of leading and lagging the waveforms, which use the very simple word or rule that we know as Eli the Iceman. So again, we are trying to learn by having dedication to each one of those chapters, especially about the AC measurement tools, and oscilloscope and the signal generators would be both of them. Then we are going to solve. We are going to calculate the RMS values, the frequency, reactance, analysis, the phase shift, and finally, we are going to build everything in our small lab itself. Finally, we do have the module number 4, which we should be about the synthesis. We are going to have the advanced analysis over the AC, and also we are going to talk about the resonance. So the key concept of this one that we are going to cover, which would be about the phasors. We are going to see and that some kind of AC quantities as vectors and something like the polar and rectangular form. It means that we can form the AC waveforms to these 2 types, and in order to use them for simplification. And then we are going to have the phasor arithmetic. We are going to master the mathematical operations for combining AC quantities, and then we are going to see the impedance, the total opposition to AC current. It means that this is the combination of resistance and reactance, and we are going to have it as a single complex value. Then we do have the series RLC circuits. It means that we are going to analyze the circuit with all 3 passive components and discovering the phenomenon of resonance. Finally, we do have the parallel AC circuits. We are going to apply the phasor analysis and admittance concept to parallel configuration. So again, as I just told you, we are going to learn. We are going to understand how resonant frequency, which we do have a very famous formula for that, is drive and its importance in tuning the circuits. We are going to solve. We are going to use the phasor diagram and complex numbers in arithmetic part in order to find currents, voltage, and impedance in series and parallel circuits. And finally, we are going to build our circuit in the lab itself. Finally, we do have the module number 5, the application. We are going to see that how we can use everything we just learned in the real world scenario. We are going to start that with the power triangle. The power triangle is the differentiating between true power, which we know as reactive power, Q, and apparent power, we know it as S. We are going to master the power factor part, and we are going to talk about it in detail. Then we are going to touch a little bit about transformers. We are going to understand the theory, why we do have them, the construction, the turn ratio, and their critical role in power distribution. Then we are going to talk about the DC motors. We are going to explore the components, stator, rotor, and commutator, operating principles and types, series, shunt, compound. And finally, we are going to have the AC motors. We are going to have some kind of introduction through the induction motors, rotating magnetic fields, the synchronous speed, and so many other kind of concepts. So at the end of this part, we are going to learn and understand why we do have power factor, why it's going to be very important. We are going to solve so many questions related to that. And finally, we are going to go to the big lab and see actually how we can use everything we just learned in this module itself. So as I just told you, in this course, it's going to be more than 35 hours of content that I have planned for that properly. We will have some kind of hours for that part, and we are going to consider
40 different chapters from everything that I just talked about it. We are going to have at least 7 hands-on labs in order to understand everything related to that, and we are going to have different kind of project. And finally, we are going to have more than 200 problems that you can solve, and you can make sure that you completely understood everything related to that. So this is going to be the complete curriculum map that I had in my mind from the chapter number 1 to chapter number 40. And finally, the results. We are going to see that what we are going to have at the end of this module. We are going to be confident about everything, about all of those information that I gave to you. We are going to be confident that we are going to have them and we are going to use them in the real world. Then we are to have practical builder. Not only we are going to solve some kind of theoretical questions, but we're also going to build them in softwares, see some kind of simulation, and finally we are going to build them in actual world. And finally, we are going to be the guy, or we are the person that is going to be creative problem solver itself. So that was everything you have to know related to this course, related to this topic. I'm so excited about that. You don't know how interesting this part is, because electrical circuit is the fundamental and the very basic part of each electrical engineer. It doesn't matter in what part you're working, as the power engineer, as a communication engineer, as anything related to that. Even when we were talking about the computer science, electrical circuit is the fundamental of everything. So let's join me in this course, and we are going to see so many interesting things that they are going to make you eager to learn more and more. My name is Mahmoud Kiosari. Thanks for watching this. Have yourself a great day, night, whatever. See you around.